Hey, today I just want to reinforce the integration by parts, right? I mean, sometimes you have something and it just looks like you think, how can these things be multiplied together and let me integrate? But it'll happen. Okay, so we're going to do one example, and I'm going to give you one question. So let's try the integral of natural log of x times the square root of x dx. Again, the integral of u dv equals u times v minus the integral of v du. Kind of a crazy process, but it'll get the correct answer. So my u can be natural log of x. My dv can be square root of x dx. So what's taken care of? Well, we've got the u, right? That's cool. And we've got the dv. That's all right. Ooh, u times v. Do I have my u? Yeah, I got my u. Hey, at the very back, integral of v du. I want my du. Well, let's take the derivative of u with respect to x. Because if I take the derivative of natural log of x, I just get 1 over x. And so I can multiply both sides by dx, and du is 1 over x dx. Okay, now it looks like I still need v. All right, there's two places in that equation that request a v. And so let's integrate. Now, of course, square root really means exponent of 1/2. So when I integrate, I add 1 to the exponent. So 1/2 plus 1 becomes 3/2, right? 1 1/2, 3/2. But then I have to divide by that new exponent. So I'm going to divide by 3/2. But of course, dividing by 3/2 is the same as multiplying by 2/3. Now, notice that when I find v, I am not putting the plus c there, right? Because this is just part of our substitution package. I'm trying to figure out what needs to substitute for these different pieces. Now, when we're all done with the question, I'll put the plus c on there, but don't put the plus c on here now, because then you're going to start integrating that constant, and it just gets super crazy, all right? So let's just leave that alone. Okay, so let's get this equation written. I need, what do I need? I need my u. Okay, we've got our u, natural log of x. dv, okay, I've got that. Equal sign. U, well, u is natural log of x. Times v. So let's go times 2/3 times x to the 3/2. Now that looks really messy, but the good news is we don't have to really do anything with it, right? Because that doesn't get integrated, right? It's just u times v. It can just sit there. I need my subtraction symbol. I need my integral symbol. V. Okay, when we integrate it, I got 2/3 x to the 3/2. And so that's my v. Du is 1 over x dx. All right, now I've got it rewritten in the correct format of u times v minus integral v du. But before I try to do my integration, I want to try to tidy this up. Right, this looks like a really bizarre thing, so I'm going to rewrite it and say, hey, you know what? 1 over x is secretly x to the negative 1 power. Right, so all I did on that step is I left everything alone except that 1 over x becomes x to the negative 1. Now, if I've got x raised to some power times x raised to some power, I just add the exponents. Right? Think about if I had like x to the 3rd times x squared, it'd just become x to the 5th. So I've got to take that 3/2, I got to take that negative 1, add them together. And of course, if you're having a tricky time with that, think of that negative 1 as being negative 2 over 2. And then might be more obvious, hey, yeah, the answer is going to be 1/2, right? 3/2 plus a negative 2 halves is 1 half. Okay, now I'm going to actually do the integrating. And again, that u times v is just going to sit there. Now, when we integrate, the coefficient's not going to do anything. It's going to sit there, so that 2/3 will sit there. I have to add 1 to the exponent. So if I add 1 to a half, I get 3 halves. I now have to divide by the new exponent. So I'm going to divide by 3 halves, which is the same as multiplying by 2/3. And now that I'm all done with all the integration, this is when I put the plus c. And there's not much tidying up I can do. I've got 2/3 times 2/3. That'll make 4/9. And then we can get into a great debate of, well, gee, do you want to just leave the answer looking like this? Do you want to factor out a common factor? I'd be tempted to say, hey, I'm going to stop. Right? Because if this was part of a larger problem and I then wanted to do something with this, I might not necessarily want to factor it, then just to have to do the opposite later. So we'll just say, hey, nope, that looks good. So, as usual, this weird, bizarre animation is going to spell out a worksheet. And like we saw on that front slide, there's a lion, a tiger, and a bear. And of course, if the order is a lion, a tiger, and a bear, you just gotta think of poor Dorothy and the Wizard of Oz. Right, so that will wrap it up with this one. I'll have one question for you, and if you can get that done, you'll be done with math until Monday.